I built a new approach for AI agents to call tools, which is open source, has zero dependencies, and works with any LLM model. Anthropic has built something similar called programmable tool calling, that is smart lazy tool discovery, but is still stuck with JSON after finding the tool. And Cloudflare went further with code mode, which executes actual TypeScript code, but needs a weird sandbox just to run a tool call. But mine does neither. No JSON, no sandbox, but just AST for parsing. Let me show you how. I have been building AI agents for a while now, and one thing that kept bugging me was how inefficient tool calling actually is under the hood. So I built something to fix that, published it as open source Python package, and in this video, I'm going to walk you through the problem and how others approached it and exactly how my solution works. And before we get into this, let me clear you one thing that I'm heavily inspired by Anthropic's programmable tool calling and Cloudflare's code mode. Here is how tool calling works today. You build an AI agent, you give it a number of tools, search the web, send emails, fetch stuff prices, whatever. Every single time the agent processes a request, your framework dumps all the tool schemas into the context window. Think about that for a while. Every schema is roughly around 500 tokens. For 50 tools, that's 25,000 tokens loaded on every turn for the tools that will never even be called. It's like handing someone an entire book, whereas they just want to read a chapter. It pollutes the context, degrades accuracy, and costs you real money at a scale. There's a better approach, like you give the agent an index and let it dynamically fetch what it actually needs. And smart people have already noticed this problem. Anthropic built something called programmable tool calling. And the tool discovery part is really clever. Instead of loading everything upfront, the agent searches for tools lazily and only pulls the tools that it actually needs. Smart. But once it finds the tools, you are still calling the JSON. Cloudflare went even further with code mode. Two tools, search and execute. The execute step lets AI agent to write actual TypeScript code in order to call tools. Powerful, no doubt. But you need a weird sandbox just to safely run that code. That's serious infrastructure for what is essentially a function call. Both are steps in right direction, but I think neither has fully solved it. That's exactly why I built AI tool executor. It's a lightweight layer that sits between your AI agent and your tools. Your agent never sees any of your tools. Instead, it gets exactly three meta tools. Search tool to discover tools it needs, execute, run them, and describe tool to read your documentation only if agent is confused about the tool. And that's it. When agent needs a tool, it calls search tools with its intent. The executor matches against name, description, and tags and returns compact function signature with description and what the tool does. This way, the agent knows exactly what to call. Then it calls execute meta tool. And here is where it gets interesting. Instead of JSON, the agent writes Python function call syntax. Same information, but the function call version uses 65% less tokens. And LLM writes function calls way more reliably than JSON, as they have been trained on billions of lines of code. The executor processes it using Python's AST model, the same thing that your IDE does to extract function name and arguments, then validates them against the registry and calls the real function. No sandbox required, no code execution risk, just safe AST parsing. You can also batch multiple calls in one shot and they run in parallel. If one fails, you still get the result from the tools that succeeded. So here's the architecture, and it is really simple. The agent at the top layer only sees three things: search tools, execute, and describe tool. That's its entire world. When it calls search tools, it goes to the tool search layer, hits register, and gets back ranked tools with just compact function signature and description about what that tool does. And when it calls execute tool, the call string goes through the AST parser first, then the validator, and only then hits the actual tool function. So by the time your function runs, everything is already verified. And describe tool is straightforward. It just pulls the full Docker string straight from the registry when the agent needs more context about a tool. But honestly, this won't get called 90% of the time. Search tools give the agent enough information to work with. Describe tool is just there for a safety net. When the agent is confused about how a specific tool works, and it is even optional to include. And finally, the registry sits behind all of this, and the agent never touches it directly. And that's the whole point. Here is what this actually saves you. While traditional approach with 100 tools would cost you around 50,000 tokens per turn, but with this executor, same thing can be done with around 600 tokens per turn. That's not a 10% improvement. That's nearly 99% reduction in tools related token users. At a scale, that difference is substantial. And because the registry never touches the agent's context directly, tool selection accuracy goes up too. And the agent isn't drowning in the irrelevant schemas. Now, before you go all on this, let me be honest about the limitations it has. The biggest limitation of this approach is it requires two round trips. First, the agent searches for tools and then it executes. Traditional tool calling can do that in a single round trip. So, if latency is critical for your use case, that's a real trade off to consider. Also, this package is still early. It works, but there are probably some rough edges for production level usage that I haven't hit yet. And honestly, my knowledge has limits there too. So if we are building something serious on top of this, I expect to do some tweaking. But here is what excites me the most. The tool searching part is completely pluggable. Right now it's keyword and fuzzy matching. But imagine swapping that out for semantic search or hierarchical tree index that gets built as you register tools, or even a lightweight model dedicated just to find the right tools intelligently. And over time, this will give developers real control. You pick the search strategy that matches your scale, your tool count, your latency requirements. Small projects, keyword search is fine. Hundreds of tools, plugin semantic search, or tree based index. That flexibility is something neither Anthropic's approach nor Cloudflare's code mode gives you out of the box. So, yeah, it's not perfect yet, but the foundation is solid and the direction is interesting. The project is completely open source and link will be in the description below. It has zero dependencies and it works with any LLM model, OpenAI, Anthropic, Gemini, local models, whatever you are using. It was helpful, drop a like. It genuinely helps me. And let me know in the comments what is your current tool count in your agents. I'm curious how bad the token leaks actually is for people. And if you want more videos related to my AI learning journey, AI projects and challenges, along with the interesting and useful AI resources, then hit that subscribe button. Here is another video for you to watch while I will see you in the next one.